We discussed before how we can project a map onto a flat plane, which is called azimuthal, onto a cylinder, which is called cylindrical, or onto a cone, which is called conic. But really, we can project a map onto any sort of 3D solid that we wanted to. And here's some examples here. We could start with this kind of pyramid-looking thing, which is called a tetrahedron. And then once we project the map on the tetrahedron, we could flatten it out and make that into a map projection. Or we could project the map from a round globe onto a cube. And then once those surfaces on the cube are mapped, then we could flatten out that cube by cutting along the edges and making this sort of map projection here. We could use a dodecahedron, shown here, which are comprised of these five-sided pentagons. Or we could use any sort of combination of triangles like this octahedron here or this icosahedron here. Once we project onto this 3D solid again, then we just flatten out the surface of that solid and we have a map projection. This is one example here, shown previously as this icosahedron example here. And this is the Buckminster for Dymaxion map projection. And he designed this in order to try to get all of the continents kind of aligned and along this. Sometimes this is called Spaceship Earth because it's supposed to show how we're all part of the a connected world here. And if we look at how this is done, basically first the globe goes onto an icosahedron. The icosahedron is cut along all of its edges, and then after it's cut along all of its edges, it's flattened out into a flat plane to produce the map projection. Of course, in all those examples, we're projecting the globe onto the entire 3D solid, but we don't have to use the entire 3D solid. In this case, this is a map projection called the Raisz Armadillo map projection, and it's projecting onto a torus. A torus is sort of like a donut shaped. It's a three-dimensional object that has a hole in the middle of it and is produced in this manner here. And we can see that this map projection shown here is just using the front of the torus, like in this area right here, in order to project the Earth onto a surface, and then take that surface and flatten it out into a map projection.